Hi, this is Andrew Goldberg. I'm going to do a quick walkthrough of Team 4's Week 5 Part 2 assignment. So what we chose to do is to look through the pre-processed Enron email corpus, which is available on this website, to classify the documents as either spam or ham. The first step we went through was to import and normalize the data. So we imported a few modules. We chose some spam folders on our desktop where we had already downloaded it. It's a large file of email, so it's a little harder to put directly onto GitHub. And then here we just read through it, make sure that it's in the correct encoding, and then append it to a list called spam data or ham data. Here's a example of what one of the emails looks like. It's very heavily encoded in UTF, and apparently it was done on Windows. The next, we formatted and labeled the emails as either spam or ham. So on this step, we took the emails, we split them up into words, and each list for each email was labeled as spam or ham. And then we randomized it so that spam and ham were mixed up within the same list of lists. Here we extracted the emails from each of from the larger list, and then we flattened it so that it was just one large list of emails. Here we then went through and did the same thing, except for this is just for emails that are classified for spam, and this is just for emails that are classified for ham, and this is for later usage. After that, we took the lists and we tokenized all the words so that we could then define the feature extractor or extract the features. We use the feature extractor, which we'll show you later. But the first step was to take a frequency count of all the tokens and figure out the most common 500 words for each. So we did that here, and then we also limited it for if they're alphabetized, or if they're alphabetized, and made sure that we got the words that were in English. Here again, we just go through the ham and the spam customized lists, and here's where we put together all the top words. Here's an example of what the most common word, a list of all the most common words look like. First of all, it's some symbolic stuff, such periods, dashes, and then we go into obviously the more common words like the, to, and then once we go a little bit further, it'll probably be like CC and some other words. And here we actually chose some features. We first looked at if the length of the email was either very long or very short. So if it was very short, it'd be under 20 words. If it was very long, it'd be over 1,500 words. And if it was neither, we would just label short email or long email as false. The next step was to use the frequency list to see how many, or to look at the top words and then we could label out if it contained any of those, top 500 words that as features. We then also looked at word length and lexical diversity. With those features in mind, we then broke out the data set into a train set, development test set, and a test set, and ran it through a naive Bayes classifier using the training set first. We looked at the predictions by putting them into a data frame and then running the actual email if it was labeled spam or ham. And in the dev test set, what classification was, the observed classification, and the predicted value of the classifier. And here is that crosstab a confusion matrix, and you can see that the ham, the true positives, well, I would say the true positives are actually the spam and the spam, which was done well. And then, but there were a few that were labeled as spam, even though they were ham. So they were false positives, or no, true negatives, false negatives, I think. And then we see that looking at the sensitivity and the specificity, the sensitivity is extremely high. It's at 1, which is as good as you can get. But the specificity, which focuses on if there are any mislabeled emails as spam when they should be ham, is not quite as high as sensitivity, although it's still quite high. This isn't perfect, as a lot of times you don't want to have to be looking in your spam folder every day. So sometimes I think email companies try to focus on maybe specificity over sensitivity, and they'd rather have some spam in the email box than missing some important emails. But we came pretty close by using all those features. It was definitely an iterative process. And then looking at the performance, the accuracy is at 0.95, which is good. And then some of the most common features that were most informative features were words like contains, attached, which are, or I mean, CC and attached, which are both significant of being a ham email, and then something like securities or act now or save money or investing are more likely to be spam. The errors, which we then looked at, we looked at the tag, the guest, the length of the email, lexical diversity, the average word length, and the modeled spam probability. And this was after an iterative process in which we've already gone through several other features that we added. And it's not clear there's any specific pattern here. As I'm going to explain later in the conclusions, perhaps something we could have done here is ran principal component analysis or factor analysis, or maybe even a regression on all different errors and try to find some other features that might be able to help us more with the specificity. But it's pretty accurate. The model performance has, using the actual test set, again, we get kind of the same data, or the same performance metrics, where there's very high sensitivity. Specificity is also very high, although it's not perfect, because there's about 288 here at about 1,000 that were labeled spam, even though they're ham. And that is it. Here's the conclusion again, which is that, the next step would be to break down possibly the errors and see if there's any other patterns within that, for which we can build some features onto it. So that is it. Let us know if you have any questions. It was a really cool assignment where I learned a lot, and I had a lot of fun with my teammates, kind of building more and more features to try to get the performance metrics, to improve the performance metrics. Thanks.